the network development on the assignment. And this one is based on the traffic demand models, which is developed by according up to the previous session. Then you need to conduct the traffic assignment. Next is, yes. Yes. Then this is the so-called the last step for the traffic 4-step models. And of course, then the transport networks will be fully utilized for the traffic assignment. Traffic assignment is the meaning that how many traffics is expected for each road and transport sections for the computerized network. Then based on for the demand forecasting, we developed the following five transport network cases. Yes, then the case 1, for example, and up to 2045, we developed the demand. We developed the transport or details in terms of the trip demand by the travel modes. Then the case 1 is the nothing cases, which is the same as the current situations of the transports. And case 2 is case 1 with existing transport network plan, which is proposed in the new plan studies, including the 5 BRT lines project. And case 3, and the upgrading of commuter railway as the urban railway is included. And for the case 4, and the additional road network is introduced. And the case 5, then the new MRT line plan. And now, today I don't explain a lot. However, for example, some of the BRT line is not enough to carry the future transport passenger. So some of the BRT lines need to be upgraded as the so-called urban mass rapid transit lines. Yes. Then first of all, I expected some of you downloaded the appendix files there. So I would like you to open the step 1 files. Check each current. Yes. It's step 1. When you need to save the network files in the CSV formats, but so many items with the column, so many columns and so many lines can be seen. Then there is no descriptions about the name of the items. So just I prepared some following items for your understandings. So let me start about the column A. Yes. So that you can compare with the existing network files which you have received previously. And the column A means the link name. This is just the ID number. And B and C is the ID number of the node. Node meaning the end point and start point of the link files. Then the length is just the kilometer length of the link. And Vmax, Qmax, the design speed and the capacity. Then QV types. Well, it will be later explained. And the fare 1 to 10. Then for the demand forecasting, the traffic assignments can be conducted up to the 10 of the transport modes, including the bicycle, motorcycle, tuk-tuk, private car, taxi, and blah, blah, blah. Then according to the vehicle types, the toll fee, sometimes they're very high. Toll is imposed for the trucks or the freight traffics for the Nairobi City Expressway. So that according to this vehicle models, the fare ratio will be assigned. And the direction, 1 to 10, yes, 1 or 2 is this vehicle models. Then the trips from zone I to J or J to I is approved. 0 meaning that this is just a two-way roads. And sometimes you can find the 3. It is the 3 is that this section is not prohibited to operate for each modes. For example, for the Nairobi Expressway, bicyclists can't go to this section. In those cases, if you have some bicycle OD trailers, for the Nairobi Expressway, everything must be 3. Such kind of regulations will be imposed. And the road type and the evaluation column, display column, this is not so used for you. However, when you fill in some forms, road type is equal 1, evaluation equal 1, the display equal 1 to 9. Yes, then the visibility of the in the network editor will be changed. The user 1 to 5, this is called as the so-called memorandum items. Yes, doesn't affect about the demand forecasting result. It's for the users remind the some form will be some items will be formed. For the user 4 columns, you can some number is fields. These numbers I put there by myself. It is meaning the code for the traffic survey locations, which is conducted in our project. Then the traffic when you compare with the traffic assignment result with the modeled transport and actual traffic counts, you can easily compare with the following number. Yes, in column 14, the sections in the user for columns is 14. Yes, this means the traffic survey sites number 14. So the traffic volumes between modeled traffic and actual traffic is compared. So to identify our assignment result, including the OD tables, is correct or not. And color is also meaning according to the 0 to 6, then the color in the you can see the PowerPoint. Yes, then I just modify in the color of the BRT lines is changed to green color, and the other links is displayed in black color. Such kind of estimations can be conducted. And this one is the locations of the I and node I and node J. And the number of midpoints, meaning up to 3 points there. You can set the 3 midpoints for the link. Then the midpoint, the locations of the midpoints can be specified like this. Everything can be modified by the network editor also. And if you want, you can modify this number in the Excel format. So that there is some freedom about the editing of the network files. So that's all for the data which is included network files. So from this PowerPoint sections, I will explain there are something include the items in the network files. Okay, next slide. Then the Vmax and the Qmax, yes, I show in the some road 30, 45, 50, 80, and sometimes 110 kilometer per hour expressway sections in the Nairobi metropolitan area. Then then the one of the topics which some of you may know already understand the sections between about the capacity settings. Yes, and there are in some road there are only 2 lanes with one direction lane and another one direction lane. And sometimes there are so-called multi-lane. Yes, with 2 or 3 lanes per directions. And one of the topics in some Japan and the United States and other countries internationally cases, the capacity settings is different between 2-lane roads and multi-lane roads. Yes, you can see for the 2-lane roads, only one lane roads, then the capacity is just 2,500 PCU per hour per 2 directions. And in the United States highway capacity manuals, the 2-lane road sections capacity will be the 1,049 PCU per hour per 1 directions. So there is some difference between the Japan and the United States. However, the figure is just in Japan cases, it can be converted into 1,250. Yes. Then you can go to the multi-lens load capacity settings, will be the 2,200 PCU per hour per lane. Then, with some the friction factors will be set rise, and the actual the traffic capacity will be decreased. However, when the multi-lane roads, the capacity per lane is actually 2,200 PCU. Seems to be nearly twice the two-lane roads per directions. Why? Yes, you can see there. You can see the private car in two-lane multi-lane roads. The car can the previous other cars, and the two-lane roads can you can. So the difference is reflected on the difference on the capacity of each sections. So sometimes, yes, in your country also, 4-lane roads are proposed to be converted to the BRT lines. So the one section must be utilized for the bus. But in that cases, the capacity for the private car will be significantly decreased. So internationally or not, but generally speaking, when you would like to convert the road section into the BRT corridors, 6 lanes is a so-called minimum requirement for the road spaces. So currently, Gong Road is just a 4-lane roads. So further expansions may be necessary for the two functions as the arterial road, especially for the public transport and private car also. I speak too much. However, the capacity and for the new proposed roads in the Nairobi metropolitan area's transport network, new road and expanded roads is defined as 40 kilometer per hour of the design speed and 40,000 PCU per day per two directions of the. So it can be considered as just a 4-lane roads. Yes, with the capacity with some good environment as for the transportation. And the expressway road, sometimes it is proposed and it can be considered as a 8 kilometer per hour design speed and 2,000 PCU per day. Yes, then actually I review the new plans transport network and utilize for the demand forecasting. However, currently I couldn't understand the regulation rule to how to specify which roads is designed, how to calculate the design speed and capacity of each sections of the existing new plans network. As the differences, I prepare and share with you about in the other studies in the other countries, including the Indonesia, Philippines, Vietnam, Myanmar, Bangladesh. Everything is Asian countries. So sorry for your inconvenience. However, based on the other studies reports, I prepared some tables about what kind of Twimax and capacity is specified for each sections. So that you can again go back to the Excel files which I shared. Step 2, reference the road design. And this column is just a paper, the title papers. For example, you can go to Oats. Yes, this is just a Indonesian highway capacity manual in urban countries, urban area. Rural areas also, yes. I'm not sure the reason. However, according to the road section, the number of lanes or some frictional factors, including according to the environment, road sections, the number of traffic capacities will be defined, and it will be reflected for the future network road transport demand forecasting assignment verbs. Then more simply, save cases. Yes, according to the number of lanes, number of lanes and the capacity, and the average carriageway widths, and the ranking of service areas, and the capacity per lane and capacity is defined like this. And according to the based informations that you can modify, you can set the premix capacity for the each road sections. And the mute these cases. But this one is also same according to the capacities and the number of lanes which is provided. Then this is mute this case. Yes, according to the road categories and the locations and the carriageway types is meaning the single mixed single sections or divided by the medians. The capacities, the maximum speed is defined like this. But there are so many ways, and according to the calibrations, if you can calibrate it based on the traffic assignment results, the actual traffic counting survey results, then you can. I think sometimes you can modify the network setting by yourselves. But I hope if you wish to develop and update the demand forecasting model by yourselves, I expected this is just very good references for them for setting for the traffic speed and the traffic capacities each road links or trans.
I can see that you are looking at the capacity per day. And how now then do you transform that capacity per day to capacity per hour, like the peak hour?
Yes, actually speaking, you can go to the metro cell. Yes. K value means just frictional factor. Time frictional factors, and the internationally speaking, just simply 10% of the frictional factors will be used. So just 10 times will be multiplied from the our passenger our capacities, because every of the capacity settings is converted by the per hour. Yes. Then the peak, so internationally, the peak hour factors is defined as just 10%. Yes, but I know that according to the traffic congestion is severe and severe and severe. And for example, Taki-san wants to leave here at 4:30. Yeah, before 4:30 to shifting to avoiding the traffic congestions. So the getting more congested or congested. The peak hour ratio must be gradual. So the 4, 5, 6. So there are 6 or 7% of the 7 or 8% of the peak hour ratio might be these cases. No, but for the easy understand, and I hope no one give a questions or comments. So that I just put the 10% of the peak hour factor, so the 10 times of the conversion that order. It will be upright. Today, this one also. This database also.
So, like for example, on that chart, sorry, go to the where we are. So, like for example, let's say there we have 10,000 PCUs.
Yes.
10,000 PCUs per day.
Yes.
So, like for the peak hour, it will be now that's or divided by 10.
Yes. Thank you. Then the 50, this one is direction value. So just put it the 50 or 55. So according to I'm not sure 55 is not so in this area. 70 or 80% of the direction value can be seen. However, it is very difficult to apply for all area of the Nairobi area. This area, only this area, maybe 75 or 85 of the directional gap can be seen. Yes, on the morning times, direction to here is very congested. At the evening times, direction to the from here is very congested, So the traffic police decided number of lanes per direction by themselves. It's causing the very no one come here, so I will speak freely. So that everyone think by themselves, so the causing the confusions about the city traffics. Please touch in the future. So the yes. So in that cases, for example, due to the such kind of situations, congestions about in the CBD, for example, you draw CBD area shows the very small capacities. For example, side friction factors or some intersection factors, and very high reduction ratio will be applied. But this is such kind of so-called chaotic situation in the CBD can be considered and to modify to revise the capacity of the road sections, the CBD. Then I think the modelers in the new plan also consider these sections and very low traffic capacities of the CBDs can be observed. However, I can't identify how. So I just keep it without confusions. But if you have, you can establish following such kind of estimations and completing some calibrations. Maybe you can prepare such kind of tables to share with the externalists, which for sharing the understanding of how to define the transport of things. Okay. Yes, then this one is according to the following items. I will explain about just the outlines, fair columns. Yes, you can see sometimes you can find the 5, and sometimes you can fill in the -50. Such kind of items is also for the public transport in the Nairobi area. And this section is road sections, and this 2 line is considered as the BRT lines, which is proposed in Congress. Then why this -50 is applied, and you can identify the positive value in the columns is the price per kilometer. So if this link length is 1.5 kilometer, 5 multiple 1.5 equals 7.5 Kenyan shillings will be imposed. And the negative values is regardless the length, the fixed price will be imposed. Then this red line is just the station entrance of the BRT. So when you pass through these links, need to pay 50 shillings. Yes. But this is just for the if this is 1 kilometer or 0.5 kilometer or 0.1 kilometer, the price must be same, 50 Kenyan shillings. And usually when you arrive and board and arrive, you need to pay 50 Kenyan shillings. So it means private road-based public transport, the fare is just considered as 5 shillings per kilometer. I'm not sure it is reasonable or not. However, the thing doesn't different with the actual situations in the Kenyan cities. Then, on the other hand, then the other incentives for the punctuality of the BRT service. I just put the 50 plus 50, 50 for the boarding and 50 for arriving. In total, 500 plus 5 per kilometer. So that when you ride a bus for 10 kilometers, you need to pay 50 shillings. And when you need to ride a BRT, 150 shillings need to pay. this is just a difference. When you modify these values, the passenger demand might be different. So that, and according to this result, some sensitivity analysis can be conducted. However, to check such kind of sensitivity of the public transport ridership according to the prices, you need to check about the value of time settings from citizens in the parameter files. Then the parameter files also will be explained in the later session today. Then frankly speaking, yes, currently I didn't introduce the toll fee for the Nairobi Express. And I reviewed some toll ratio in the for class 3 だから just the standard toll fee for the expressway users. Then the way we can identify from the Nairobi restaurants to Morongo 500, 410, 33, 25, 25. Like this, yes. Then I'm not sure that this is based on the distance. Yes, maybe this is based, some partly depend on the distance. However, the fixed or specific toll ratio can't be upright, as shown in the previous pages. Yes. So it is very difficult to identify what kind of toll ratio must be introduced for the Nairobi Express. So this is currently my concerns, and based on the distance between the toll sections, toll gates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you can modify or you can discuss what kind of toll ratio must be introduced for further upgrade of the transport network. Yes, this one is a direction for currents for the topic by each section for mode 1 to 10. And this show visualize about the direct so-called direction columns for mode 3 private car. And this one section is BRT. Yes. Then the BRT is the combinations of the one-way links and one-way links. And one of the items, these sections, as I explained, this is a station link, and station to platform links. And everything tree is defined for private car users. So the car can't access to there, of course. Like this. Then for the highway assignments, the BRT access by the private cars must be restricted. Otherwise, everyone use the car this section is occupied by private. So as a result, the ridership also will be decreased significantly, and you can't reach to the so-called prioritized the preferred results. Then the ones of fixed for the one-way links, the traffic is assigned to the full capacity of the links. And when you define for the two-way links like these black color sections, the traffic and the capacity setting in the Qmax will be divided into half. And by the directions, the traffic is assigned. But this is just for the forecasting network. Yes, and the user flag parameters is as I explained before. You can set the free number as you like. Then when you can convert to the GIS shapefiles from the network to the GIS shapefiles, and you can check what kind of colors is filled the following links. Then this figure is just what I visualized, including what kind of sections is classified. 0 is existing roads, and 1 is upgraded sections, which is proposed in the new plan. And the pink line is a new road. And 3 is the existing but the expressway sections. Thika Road and the Nairobi Expressway. And the green one is the BRT. Blue one is the commuter railway. And this sky color line is the transit sections. And if you can check the capacity, the ridership or traffic volumes on the transit sections. And the section with high transit volumes can be identified as a so-called intermodal facilities, which the DG is more interested in. So there are such kind of analysis and the exercise can be conducted in the demand forecast sessions. And I also prepare some GIS shape files, which can be visualized for the to prepare such kind of figure. However, I'm not sure anyone can install QGIS or can use. So let me skip about these things. The person who are interested in the GIS can open the shape files which is included in the folder and can check files. Then the step 4 is also a little bit difficult explanations. However, when you try to develop new expressway or new bridge or new railway or BRT, and how to develop in the networks is outlined in these pages. So when you can check, yes, for example, based on the GIS or other KMZs also, the locations, meaning the latitude and the longitude of each station can be picked out like this. Yes. And yes. For example, zooming these sections, this is the Nairobi Central Railway stations and train stations. I'm not sure this name is correct one. Nyayo Station, Statsumo Universities can be developed. And each stations can be coded into the C1, SA001, 002, and 003. And as I explained before, then preparing the platform nodes for each station, which is adjoining this section. You can click. Yes, like this. Following the 3 stations, the 3 nodes can be developed by nodes. Then you can connect the links in folder. This one is a so-called carriageway sections and bounded by direction. And next, some station access, station to platform access links also can be developed like this. Then when you develop such kind of railway network with the combinations of the links between platform and the links between stations and platform, you can merge with the existing network files. Then you can check and observe in the network editor. So, yes, you can like this modify the alignment by making the midpoint, 3 midpoints and modifying the sections. Not the same with the actual traffic alignment and modify the lengths for manual. Yes, and according to this point, tools, you can modify the links, the locations of the node and midpoint node as you like. So the user-friendly interface of the network editor, you can modify the transport network, which will be proposed in the city or the metropolitan area project. Can you go back to the next? Yes. This column showing what kind of exercise was conducted in these pages. Yes, according to the stations, the locations of the X and Y is picked up and the coding is developed. then the providing the platform nodes, which is closely located over the stations. For example, the locations of the station A is specified. The station B and station 3 is just the adjoinings of the station. Then you can just link to the each nodes between the platform to platform and station to platforms. Then the following items is can be copy and paste and moved to the step 1 files, which is X. Yes. And the link name node IX and the following items also can be just a copy and paste. And so that as a result, you can easily introduce the new project in the existing transport network files. But this is very difficult to explain by myself. But it is very easy to do it by yourselves. However, according to the time constraints, I will skip about the practical exercises, just like my explanation is. Then the following pages just showing about the difficulties or problems which you may see. Yes. And yes, generally transport links are connected by the nodes. Yes. And for example, if such kind of ground road intersections is be there, like this around the cities, then the section must be divided by this node. If there is no such kind of nodes, this car, for example, one car from here, only go to there also. If there is no node between this link and links, this is just a flyover will be there. So that everyone can't go from this directions. So they're causing the very so-called strange behaviors along the cities. On the other hand, like the Nairobi Expressway, if such kind of flyovers with over the roads, the flyover sections can be converted into such kind of bikes will be there. But I'm not sure there are some entrance or existence located in this area. However, if such kind of road section is there, some bypass sections can be converted and don't connect with these sections in that cases, because this is a flyover. Such kind of effort is necessary to formulate the actual traffic conditions in the cities. And sometimes it is a little bit difficult to check then this link is really connected or not. However, you need to carefully check the connectivity of each link. But this is just a tips for the demand forecasting network. Then next one is this is a little bit difficult figures. However, there is some methodology, the potential assignment and actual assignment. For example, BRT. Yes, when you introduce BRT or most rapid transit, there must be the capacity. Yes, of course. Then up to some operation plan. For example, BRT can operate the 20 times of the public transport in maximum. In that cases, the capacity also must be introduced in this area. So the 5 meaning 5,000 PCU a day is the current maximum capacity for the BRT today, according to the my assumptions. On the other hand, the potential assignment is such kind of capacity is removed. So the 1 million PCU per day is introduced. It is not realistic. So sometimes you may not care about such kind of situation. However, if the demand forecasting is conducted for both cases and when you showing the significant difference between the potential assignment and actual, so-called actual assignment, you need to conclude, oh, there is a so-called potential capacity for this corridor. Yes. So actually speaking, when you develop for the 2030 or 2035 OG tables and conducted the actual traffic assignment and the potential traffic assignment, there is a huge differences for the traffic volumes on the BRT line trees, Gong Road sections, the eastern sections, BRT line tree. It means currently these corridors have a high potential of the passenger demand. So that in near future, I'm not sure 2030 is possible or not. However, they need to consider to upgrade or more frequent or more capacitive public transport models, including the mass rapid transit.